Hello everyone, welcome back to Python Challenge for All. Okay, let's see where we were last time.
So we were playing with a name list. So I put a name list in the description box below. So copy and paste and did some basic operations such as append, in, and something like that, and sorted. Okay, let's continue. Go back to the code and do the homework. What is John's position in the alphabetical order? Maybe John was not in it, so we need to append first. So let's go see what. So here, open E4, connect, and let's see. Let's do the box again so that we have 12 names in it, starting from Emma to Logan. And we found that Mary was not in there. So, and also John was not in there. So I first appended Mary as the 21st element. Okay. So homework was John's position in the alphabetical order. Maybe after, I forgot to write that maybe I need to do it after appending John at the end and sorting. So let's see. Maybe we can do as this. So now let's check again. Names, the length is 11 and say, okay, x equals, did we use x here? We used y. Okay, so let's call John as j, variable name j equals John, and John in names, it returns false. Okay, so let's put John at the end of names, append j, and let's ask j in names. Of course, it returns true. Okay, and also the length is 21. Well, was it 21 or 22? I forgot whether Mary is already in there. Okay, both Mary and John are in there. So what is John's position in the alphabetical order? So let's find out. So L2 maybe is sorted names. And then to see where John is, that's names, index, J. Okay, this will give the John's position. I forgot. It's not names, but L2. Okay, so John's position is 11 in the alphabetical version of the names list. Let's check whether L2, print L2, and also print 11 in L2, and also print L2. Okay, so 11th element is correctly John, and in the alphabetical sorted version L2, John is like after James. Okay, fine. Okay, let's continue our work. So happy numbers, it's a bit complicated story. So let's slowly check that. Let us locally define a happy number as follows. Starting with any number n, replace it by the sum of the square of its digits. Okay, so it's single digit and then square. The version is the next. And if it's several digits, square each and get the sum of each. Repeat this, and if eventually equals to 1. if this process eventually goes to 1, the initial n is a happy number. For example, if we start from 7, okay, 7 square 7, it's 49, and then square each digit, like 4 squared and plus 9 squared, meaning 16 plus 81 equals 97. So and then square 9 plus square 7, okay? So 81, which is 9 squared, plus 49, which is 7 squared. The sum is 130, okay? 130, then square of each digit, like 1 plus 3 squared plus 0, then it's 10, okay? 1 squared plus 0 squared equals 1. So it got to 1. So the first number 7 is happy. Otherwise, the initial n is unhappy. To find when shall we stop the process when we can't go to 1? Then, yeah, if any same number appears again, maybe we don't need to go continue it, because we will never go to 1, but repeat the cycle. Do you understand? Okay, so let's see how to find out whether any number is happy or not. So how we calculate the next number and complete the process? First, calculate the next number. So implement this. Change the number. To do that, think about it. Yeah, I'll give you a hint. Change the number to a string and put it into a list. Okay, let's do it. Okay, so let's make a title box with happy number. Okay, so if the number is n, n1, say n1 equals, say, 7, what we need to do is change it to, okay, let's think 17, okay? Let's take a 17th case. If we change it to 17, then we have, what do we have? As we know, S1 is string 17, which is a list of string characters 1 and 7. So if we have a list like this, okay, put it into L1. Well, we don't need it actually, S1. And then if we print each of its digits, what we get? Actually, we get 7 numbers, 1 and 7 for each. So if we multiply it by itself, get the square of the number, we got 1 plus 40. So if you get the sum of each, sum of the list, we get 50. This is what we wanted, right? So this is N2. Let's write the process again. N1, then S1, then L1, and 2. Okay, let's see the process. So first is numbers, integer 17. Next is string. This is a little bit confusing. So maybe we can change it to list, so it is clear. Okay, 17 is changed to list of characters. Then each is changed to, that's right. Okay, I see. Then we don't need this. Okay, so change to 17 and N2. Okay, so L2 is D for integer of int D for D in L1. And then L3 is D squared for D in L2. And sum is L3. Let's see. If we calculate this, maybe you can know that we can do the process of going forward in the list. So S1, L1, and L2 is, no, sorry. This should be L2 and N2. Okay, let's continue this. So, okay, now we can know that from 17 changes to string, and then each character is picked up, changed to the integer, and then each integer is squared, and then summed. Thus, we can get the next number 2. Okay, that's fine. Okay. Change each digit to an integer, calculate the squares, and sum them up. Thus, we can get the next number N2. So repeat this and check the termination condition. So using a terminating condition is a bit strange because we need to find out whether next number. So actually, we can do starting from N1, 17. Let's print out one by one the process. Let's see, for I in range, well, 20. Let's print out. So starting from N1, what we need to do is do this, okay? So maybe, how about L1 is string of N1, then L3 is D squared for D in, I see, int, okay, int D times int D for D in L1. And N2 is sum L3, okay? And then print, maybe we can write print N1 here. Let's do, I see, okay, let's do the work. Okay, let's write N1, L1, L3, and N2. Okay, and then put N2 to N1 and repeat the process. Okay, let's write this. Okay, this is I. Okay, up to 20 times. I in, sorry, this is wrong. For I, for I, for I, for I, for I, for I, or in range. Okay. Okay, so let's check. Starting from 17, 1 plus 49, which is 7 squared. Sum is 50, okay? 50, 50, 25, 0, 25. 25 is 2 squared plus 5 squared, which is not 29, okay? From 29, 2 squared plus 9 squared for 81, which the sum is 85. 8 squared, 64 plus 5 squared, 25, sum is 89. From 89, 64 plus 91, 145, very, very long. Continuing this, 1 plus 16 plus 25 is 42. 16 plus 4 equals 20. 4 plus 0 equals 4. 4 squared is 16. 1 squared plus 6 squared is 37. 9 plus 49, 58. And 25 plus 64, 89. 8 squared plus 9 squared equals 145. And then, okay, here, let's continue something. Let's change that we have 89 here, and we have 89 here. So if you continue this from 89, the same loop will continue and go to 89 again, meaning that we will continue this loop forever. Thus, now we know, after getting 89 here, we know for sure that we will never reach 1 in the loop, in the process. So the trick is we will keep all the numbers in the list. If we see the same number twice, we will terminate the process and declare that the initial number is unhappy because it will never go to 1 again. Okay? So we can implement this like this. So to do that, we will prepare an empty list such with a name, say, scene. And if we do this, append it to scene, append the number n1 to, say, let's do it here. Maybe we can do it here. Scene, append n1. Okay? And before that, we can check if so n1 equals 1, then okay, print f happy. We should remember that initial number is n0, okay? Initial number is n0, okay? So n0 is happy. Good news. Else, if n1 in scene, as we saw, we will never. Maybe we can do this here. Okay, maybe we can do this here. If n2 in scene, then maybe we can, yeah, and then break. Here again is unhappy. and we can break. Okay, let's let's copy this and paste it here, and also have a scene list to check whether this works fine. Okay. Scene is not defined. Seam, not seam, but scene. Okay. So here, what we have is we do the same process. Okay, and put 17 in the scene list. 50 is added. 25 is added all the way down. And then, as we have 89 here, 89 is in the scene list. So as soon as we get to 89, we find that 89 is already here. We can declare that 89, we can declare that the initial number 17 is unhappy. Okay, this is the way to find out. Pretty confusing, right? Maybe it might be difficult, but please check quickly yourself, check thoroughly yourself to see this is a good process to find whether any number in N0 is happy or not. Okay, that's all for today. I will surely come back to this topic again in the next lesson and check what we can do about this for bigger numbers. Okay, that's all for today. Thank you very much. And be sure to come back. There's no homework. Bye-bye.